Hello, and how are you doing, guys? In this video, we will go through 20 sample questions and answer them in detail to help you prepare for the AZ-700 Designing and Implementing Microsoft Azure Networking Solutions exam. I will leave a link in the description for the entire AZ-700 practice test. I've also compiled the AZ-700 study guide on my website. Be sure to check that for your exam preparation. Please subscribe to my channel as this really helps me to continue making such videos, and in case if you don't see tests for any Microsoft certification on my channel, please leave a comment. I will create a video on that. So let's get started. You are a system administrator and you need to create and set the IPsec IKE policy on a site-to-site VPN connection. The following are the steps, not necessarily in the right sequence, to create and update the policy. Arrange these steps in the right sequence. To create a site-to-site VPN connection and set the IPsec IKE policy, first create a VNet and an Azure Virtual Network Gateway. This gateway connects Azure VNet to your on-premises network through a site-to-site VPN connection. So step 2 comes first. Next, create a local network gateway in Azure that represents the VPN device in your on-premises network. Here, you specify the IP address of the on-premises device to which you will create a connection, and also the address prefixes located on your on-premises network. So, step 1 comes next. Once you have both the gateways, you are ready to create a connection. Next, you configure an IPsec IKE policy by selecting an algorithm and setting different parameters within the VPN connection object that ultimately connects your local network and Azure VNet using the IPsec protocol. Next is step 3. Finally, you create this connection object with the IPsec policy, which is step 4. By looking at the steps in the portal, you might be tempted to swap steps 3 and 4 since you create the IPsec policy within the VPN connection. But while creating the objects via PowerShell or any other command line tool, you would first create the IPsec policy and then use this policy while creating the site-to-site VPN connection. So the order is B, A, C, D, E. Option A is the correct choice. You decide to create a point-to-site VPN connection to connect you to your virtual network from home. In this case, point-to-site VPN can use any of the following protocols except Point-to-site VPN uses one of these protocols like the OpenVPN, which is a TLS-based VPN protocol that connects devices across all platforms like Windows, Android, iOS, and Linux. Then there is the SSTP, which is also a TLS-based VPN protocol supported only for the Windows devices. Finally, we have IKE version 2 for Mac devices. You can also verify this by trying to configure a point-to-site VPN connection in the virtual network gateway. For tunnel type, we have only OpenVPN, SSTP, and IKE v2, and there are some other combinations of these protocols. As seen in the previous question, IPsec protocol is used by the site-to-site VPN. It is not used by point-to-site connections. Option C is the correct answer. An ExpressRoute circuit denotes the logical connectivity between MS Cloud services and on-premises infrastructure via a connectivity provider. Which of the following statements are true about ExpressRoute circuits? When you create an ExpressRoute object in Azure, you can see that a service key is associated with it. Also called the S key, this is a unique key for the ExpressRoute circuit. So option B is one of the correct answer choices. And so is option E, which just states the same thing in different words. And you can enable peering or routing domains on the ExpressRoute circuit like Azure Public, Azure Private, and Microsoft to enable secure access of Azure and Microsoft 365 services from the customer network. You can enable either just one or all three peerings on the ExpressRoute circuit. So option D, which says that there is a one-to-one mapping between ExpressRoute circuits and routing domains, is incorrect. And so is option C, which says that you can enable just 2 peerings per ExpressRoute circuit. Finally, ExpressRoute circuits do not map to a physical entity, so option A is also a correct choice. While accomplishing your task, you need to centrally develop, enforce, and log applications and network connectivity policies across virtual networks and subscriptions. Which of the following services would you use? Option A is incorrect. Azure Front Door is a Layer 7 load balancing solution for web applications. It is related to improving performance of your app and not to network connectivity policies. Option C is incorrect too. Azure Private Link allows you to access Azure PaaS services like Azure Storage and SQL Database over a private endpoint in your virtual network. This service simply connects your VNet to Azure services without the need for a public IP. Option D is incorrect too. Azure DNS offers name resolution with the help of Microsoft Azure infrastructure. Option E is also an incorrect choice. Azure DDoS protection offers protection against DDoS threats. Option B is the correct answer. Using Azure Firewall, you can create, enforce, and log application and network connectivity policies across virtual networks and subscriptions. The domain name system resolves or translates a service name to an IP address. Which of the following record types can't be used by Azure Private DNS? Well, Azure Private DNS supports all common DNS record types like a record, which points a domain to a IPv4 address, and a record, which points a domain to a IPv6 address, and other records like mail records and text records. But AA is not a record type. In fact, if you analyze the DNS packet structure, the label AA is one of the flag fields in the DNS query header. It stands for authoritative answer, which specifies whether the responding name server is an authority for the domain name in question. For example, if I do a NS lookup for my domain ravikarans.com, I get a non-authoritative answer, which means that the response came from a name server that is considered non-authoritative for my domain. So option C is correct. Even AAA is not a type of record, and I have not seen where this is used in the DNS world. In case you know, please let me know in the comment section. For this question though, option D is also a correct choice. You can use virtual network peering to seamlessly connect 2 or more virtual networks in Azure. Which of the following benefits would you get using the virtual network peering? Select all that are applicable. Virtual network peering enables you to seamlessly connect 2 or more virtual networks in Azure. Both networks appear as one, so peering provides a low latency, high bandwidth connection between resources in different virtual networks. So option B is incorrect and option A is one of the correct choices. When you peer 2 virtual networks, there is absolutely no downtime to resources in either virtual network during the peering process or after the peering is created. So option C, which talks about downtime to resources in virtual network, is also incorrect. And option E is a correct choice, as that's exactly the reason why we peer 2 virtual networks, to let resources in different networks communicate with each other. Finally, you can peer virtual networks across deployment models, either the Azure Resource Manager model or the classic deployment model, across Azure subscriptions, across Azure regions, and across Azure AD tenants. So option D is also a correct choice. Basic and standard are 2 types of virtual WANs. Both WANs support different configurations. From the given options, select the configuration that's available for a basic virtual WAN. Azure Virtual WAN lets you connect your branch offices, your data centers, your remote users, your company headquarters with Azure Virtual Networks via a site-to-site point-to-site and ExpressRoute connections. But not all configurations are available with a basic virtual WAN. Here I have already created a basic virtual WAN, and when I create a new hub, it lets me create a gateway for site-to-site connectivity, but not for point-to-site or ExpressRoute connectivity. You need to upgrade the virtual WAN to a standard tier if you need those configurations. Option D is the correct choice. While working on Azure PowerShell, some of the values mentioned in the instructions are getting failed. One of your friends suggests you ensure that you have installed the latest version to avoid such issues. Which of the following commandlets would you use to find the versions of Azure PowerShell that have been installed on your computer? All Azure PowerShell commandlets follow this standard naming convention, which is verb-noun, where the verb describes the action to be performed and the noun describes the resource type. And these are the commonly used verbs in Azure commandlets. To view information about the PowerShell version used, use the verb get. Retrieve is not a verb used in PowerShell commandlets. So options C and D are incorrect. To view the PowerShell version installed, use the command get module list available AZ. Option A is the correct choice. While working as a network administrator, you need to do DNS-based global routing. Well, let's stop reading this question here. Of all the load balancing options in Azure, DNS-based load balancing means it most probably is Azure Traffic Manager. A listener is considered a logical entity responsible for checking the incoming connection request with the help of the protocol, host, port, and IP address. When you decide to create a new listener, you have to choose between basic or multi-site. Scenario is, you want the incoming request to be forwarded to a different backend pool depending upon the host names or the host header. Solution is, you choose a basic listener. Is this the right choice? Well, a listener is a logical entity that checks for connection requests from the incoming traffic to the application gateway. There are several parts in a gateway architecture like front-end IP, listener, rule, and a backend pool. So before answering this question, let's go to Azure portal to understand the role of Azure listeners. When you create an application gateway, you define a front end where the gateway receives the traffic and a backend pool where the traffic is routed to. In between them, you create routing rules. A routing rule sends traffic from a given front-end IP to one or more backend targets. And a routing rule contains two parts, a listener and a backend target. The role of a listener is to listen on the specified port and the IP address. If the criteria that you define here is met for any listener, the application gateway will apply this routing rule and route the traffic to the specified backend target. But when you define a listener, there is a setting called listener type, which can be either basic or multi-site. If you are hosting just a single site behind an application gateway, choose a basic listener. In this case, all requests are forwarded to the same backend pool. On the other hand, if you want to configure multiple web applications behind the application gateway, choose a multi-site listener. Application gateway relies on HTTP headers to host more than one website on the same public IP address and port. So if you want the incoming request to be forwarded to different backend pools depending on the host header so that you can host more than one website, you should choose a listener of type multi-site. In the given scenario, using a basic listener does not solve the problem. Option No is the correct choice. You address your team about various Azure load balancing services. Which of the following statements would you use to describe the Azure front door load balancing service? Check this table, which guides us how to choose a load balancing solution based on these two parameters. Azure Front Door provides a global load balancing solution, which means they distribute traffic across different Azure regions. Regional load balancers distribute traffic within virtual networks in a region. And Azure Front Door operates at the layer 7, which means they accept HTTP or HTTPS traffic, which also means that they are intended for use with web applications. On the other hand, Traffic Manager and Azure Load Balancer handle non-HTTPS traffic and are recommended for non-web workloads. Given this understanding, we need to look for an option that is suitable for load balancing web applications globally. Option A is incorrect. Although the service operates globally, it is a DNS-based load balancer. Of all the 4 load balancing solutions in Azure, only Traffic Manager is DNS-based. As for each DNS query received, Traffic Manager uses DNS to direct client requests to the appropriate endpoint. Option B talks about Layer 7 Application Delivery Controller. It describes application gateway. Option C talks about Layer 4 of the OSI model for TCP and UDP protocols, so this statement describes Azure Load Balancer. Option D says that it is a global load balancing solution with Layer 7 capabilities. This statement perfectly describes Azure Front Door and is the correct answer to this question. Also search for load balancing Help Me Choose service in Azure, where we will re-verify our understanding from earlier discussion. DNS-based is Traffic Manager. Layer 4 is Azure Load Balancer. Layer 7 means it is either of these 2 options. But generally, Front Door operates at the global level. Further, only Front Door provides site acceleration service, which you can verify from the service comparison table. There are 6 traffic routing methods in Azure Traffic Manager to control traffic to different endpoints. Which routing method would you use when you have endpoints in various geographic locations and you want to ensure that end users utilize the closest endpoint for the lowest network latency? These are the 6 different traffic routing methods in Traffic Manager. So right away, options B and D are incorrect. In Priority Traffic Routing method, the Traffic Manager profile contains a list of endpoints with priority values. By default, Traffic Manager sends all traffic to the highest priority endpoint. If the highest priority endpoint is not available, then it routes the traffic to the next highest priority endpoint. This method enables us to implement a failover pattern and it doesn't address network latency. Option A is incorrect. In a weighted traffic routing method, instead of priority values, weights are assigned to each endpoint. For each DNS query, the Traffic Manager chooses an endpoint based on the relative distribution of weights assigned. For example, if endpoint A is assigned a weight of 70 and endpoint B is assigned a weight of 30, then Traffic Manager routes requests to endpoint A 70% of the time. Even this option is incorrect. What we need is a solution that takes into account the geographic location of the user and directing to the endpoint nearest to the user. That's exactly what Performance Traffic Routing method does. In this method, the Traffic Manager maintains a latency table to track the round-trip time between IP address ranges and each Azure data center. For example, if the user comes from this IP address range, then Traffic Manager exactly knows which endpoint is closest to the user in terms of latency. And so it directs the user to that endpoint. Option C is the correct answer. Virtual Network NAT uses outbound only internet connectivity for virtual networks. Which of the following statements are true about NAT? Well, a NAT translates a private IP address to a public IP address, so multiple devices in your private network can access the internet through a single public IP address. NAT enhances security for private networks by keeping internal addressing private from the external network. To answer the given question, let's try creating a NAT gateway in Azure. NAT is generally associated to a subnet in a VNet and can be used by all compute resources in that subnet. So let's select a virtual network and a subnet to associate with the NAT gateway. Before proceeding further, look at the information here. It says that subnets with any of these resources are incompatible and cannot be used to associate with a NAT gateway. For example, subnets with IPv6 address space. NAT supports only IPv4 and not IPv6 address spacing, so option C is a correct choice and option B is incorrect. Further, NAT is not compatible with basic resources like a basic SKU load balancer or a basic SKU public IP address, but compatible with their corresponding standard SKUs. So option A is incorrect because it says that NAT is incompatible with load balancer resources. As we just learned, NAT is only incompatible with basic SKU load balancer and not just any load balancer. So let's proceed to create the NAT gateway. Once created, let's go to the subnet section and try to associate subnets from other virtual networks to this NAT gateway. Just observe that first, the previous subnet is disassociated and then the new subnet from another VNet is associated, which means you can only associate subnets from a single virtual network to a NAT gateway. But within a single VNet, you can associate more than one subnet to the NAT gateway. So NAT cannot span multiple virtual networks. Option E is a correct choice and option D is incorrect. You protect your Azure virtual network resources using Azure Firewall, but there are a number of different issues with the firewall. For the issue, threat intelligence alerts may get masked. How can you mitigate the issue? Each option represents the complete solution. Select all that are applicable. Well, to begin with, Azure Firewall provides threat intelligence-based filtering, which alerts or denies traffic from malicious IP addresses and domains. You can set the threat intelligence mode to either alert only, in which case it just alerts you about the malicious traffic, or alert and deny, in which case it alerts you and blocks the traffic. Before using Azure Firewall, be aware of some limitations or known issues of the service. And one such issue discussed in the question is that the threat intelligence alerts provided by Azure Firewall may get masked by network rules with destination ports 80 or 443 if you have configured the threat intelligence alerts to alert only mode. Microsoft offers two different solutions to fix this issue. First solution is to update the threat intelligence mode to alert and deny. The second solution is to create an outbound filtering for 80 and 443 using application rules. Options B and C are the correct answers. If the first network interface allocated to an application security group is in a particular virtual network, then all subsequent network interfaces allocated to the same application security group must exist in the same VNet. Is this statement true? Well, application security groups enable us to group VMs in a VNet according to their application roles. For example, here, these three application security groups group the 9 VMs according to the roles that they perform. You can use them in a single rule in NSG to block traffic from any of the web server VMs to the DB server VMs, rather than creating multiple rules with static IP addresses of individual VMs. Coming back to the question, to test the given statement, I created 2 VMs in 2 different virtual networks, my VM1 in my VNet1 and my VM2 in my VNet2. For my VM1, I have already associated its network interface to an application security group. Let's associate the network interface for my VM2, which is in a different virtual network, to the same application security group. The interface says that the application security group cannot be used because this network interface doesn't exist in the same VNet that the first network interface assigned to the application security group is in. So the given statement is true. The question is long-winded and it basically asks what is the PowerShell command you would use to configure a security policy on a resource group that contains Azure Front Door profile. Azure PowerShell commands come in the form verb-noun, and nouns in Azure PowerShell always start with the prefix AZ. So option D is incorrect as the noun starts with the prefix Azure. Configure means to set up, to build, and so on. So the command should start with the verb new and not set. Option B is also incorrect. The question talks about a security policy with respect to Azure Front Door. Option C doesn't give any indication of what kind of policy it is. Option A looks like the most suitable choice. With Azure Front Door, you can configure a web application firewall policy or a WAF policy to protect your application against common exploits and vulnerabilities like SQL injection. With the help of PowerShell, you need to retrieve or get an existing workspace in a resource group. Which of the following commandlets would you use? As already discussed in one of the earlier questions, retrieve is not a verb used in PowerShell commandlets. Option C is incorrect. And the verb new creates a resource. We don't use the verb new to retrieve a resource. Option E is also incorrect. In this question, workspace refers to a log analytics workspace. So clearly, option A is incorrect as it tries to retrieve a network security group. To retrieve the information about a workspace, use the command get AZ operational insights workspace. Option B is the correct answer. Azure Private Endpoint acts as a network interface to connect you to a service powered by Azure Private Link in a private and secure manner. Being the private link resource owner, or in other words, owner of these PaaS services, which of the following actions can he perform over a private endpoint connection? Azure Private Link enables you to access PaaS services like Azure Storage and SQL Database over a private endpoint in your virtual network. All the traffic between your VNet and the PaaS service travels over the Microsoft backbone network, so you don't have to expose the PaaS service to the internet. Since you consume the PaaS service from your VNet, you are the service consumer and the provider of the PaaS services is the service provider, or he is also known as the private link resource owner since he owns the resources. Have a look at this approval workflow of how a private link connection is negotiated between the consumer side and the provider side. After a service consumer creates a private endpoint in his VNet, he sends a request to the service provider. The service provider or the resource owner can then either review, approve, reject or delete a private endpoint connection. Option E is the correct answer. You can get the current service tag and range information by downloading the JSON file or programmatically adding it as part of your on-premises firewall configuration. Which of the following can be used to programmatically retrieve the current list of service tags? A service tag is used to create inbound or outbound security rules in a network security group. A service tag is a predefined identifier that represents a group of IP addresses used by Azure services. For example, the service tag storage.australiacentral represents IP address ranges used by Azure Storage in the Australia Central region. Rather than using individual IP addresses, use service tags for easy maintenance of network security rules. Microsoft automatically updates the service tags as the underlying IP addresses change. You can programmatically retrieve the current list of service tags together with IP address range details with either REST, PowerShell, or Azure CLI. Option D is the correct choice. Here is an example of how we can use PowerShell to view all the IP address prefixes used by Azure Storage. Regional VNet integration enables connecting to a VNet in the same region with no need for a gateway. While using VNet integration with VNets in the same region, which of the below Azure networking features would you use to block outbound traffic? Well, App Service VNet integration has two different variations. Regional VNet integration, where you connect the app to the virtual network in the same region, and cross-region VNet integration, where you connect the app to a virtual network in other regions. You don't have to worry about the inbound traffic to the app from the VNet, as VNet integration only gives your app access to VNet resources, but it doesn't grant inbound private access to your app from the VNet. And you can block this outbound traffic from your app to VNet with an NSD that's placed on the integration subnet. Option E is the correct choice. Option A is incorrect because although you can place a route table on the integration subnet, a route table just routes the traffic and it does not filter or block the VNet traffic. Other options like front door and traffic manager do not make sense as they are not placed on a subnet. Once you are done, let's submit the test and verify the performance. So if you are preparing for the AZ-700 Designing and Implementing Microsoft Azure Networking Solutions exam, check the description for the link to the entire practice test that cover the length and breadth of all the objectives in the exam. Also check out my YouTube channel. I have already covered the sample exam questions for other Microsoft certifications, and in case if you don't find them for any Azure certification, I will be happy to create a video on that. As always, share the video and please do subscribe to my YouTube channel because more videos are on the way. Thank you.